Hi everyone, today we continue our lesson of the transformations. Okay, last periods we learned transformation of the sine, cosine and tangent functions, and the last period we talking about the vertical translations, and today we're gonna learn about horizontal translation. Let me review a little bit about we learned last periods, not a few periods, okay, about the vertical translation. Uh, See, for example, I give you this here, function y equal to negative 2 sine x plus 3. You can observe here, number 2 here, right? This is a transformation step. Okay, y equal to 5x, sine x, that's the first one. And second graph and be y equal to 2 sine x, and third and fourth here. So now we want to review a lot about the translation, vertical translations. So at the number 2 here in front of sine x, we call direction, okay? Because the transformation, see this word, okay? Transformation, we have three kinds, right? First, we call dilation, okay? And the second one is translation. And the last one is a reflection, okay? So we learn most of our past lesson is a dilation, because you see number 2 here is a dilation. We call vertical, number 2 here, vertical dilation. Dilation means the gap be wider, gonna be wider or narrower. Sometimes we call stretching or shrinking, vertical stretching or vertical shrinking. Depend on here the number right on the font. Say we say let our 2 become like a here, right? So we observe if our a, say if our a greater than 1, okay? So this, when you plot graph, the graph gonna be larger, right? The value of y gonna be larger. This one we call vertical stretching, or the expansion of the graph, right? Okay, so if our a if our a less than 1 but greater than 0, that means our a between 0 and 1. That means our 2 here gonna be, for example, like a fraction number, can be like 1/2, 1/3, 2/3, 3/5, something. So if in the second condition, if a between 0 and 1, our graph gonna be, the value of y gonna be smaller, right? This one we call vertical shrinking, or sometimes we call, like we learned last year, we call compress, right? The graph is vertical compress. The graph is compressed vertically from the previous graph. Okay, so this the one we learned from last year, right? Next, just see next one, the position here, the number 3 here. This 3 is there's a second of transformation. The first one dilation. Number 3 is a translation, because number 3 here is still vertical, correct? Previous classes we learn vertical. Because number 3 here we call vertical translation. Like this one, number 3. In this case, we're gonna call vertical translation upward, right? Because plus 3. See? So this one, translation upward or downward, vertically, right? Translated vertically upward or downward. Depend the plus or minus sign here. So that's a translation. Okay. So now the reflection, what related to the reflection? Same thing, you observe here the number negative sign here. Okay, or according graph number 3 here, you have negative sign. So your graph will reflect it from the previous graph, or just flip in x-axis. Okay, everyone recall or not what we learned? Did you remember? If not, you have to go back to see your handout last year and review it. Then when you do the question about transformation of sine, cosine, tangent, gonna be easier because they use the same idea. Okay, so now today, what the horizontal translation, we're gonna learn this one most. You observe here, is about here. Because when you talk about x inside here, we talk about the horizontal translation. We're concerned about the horizontal. If the outside here, we just finished, I just explained, that's a vertical translation or vertically of the dilation. The graph will wider, narrower, will shrinking or stretching, something like that. Okay, so then today I will give you example, this one, for example. Say our y equal to 2 sine 2x plus 3. Now you observe this one, okay, what the difference right here. Because we have 2x now here, okay. Before we have only 1x, we have only 1x. And come back to this question. Like we have y equal to sine x. How do we know this? The one complete cycle equal to 360 degrees, because we have one formula, period formula, equal to because sine cosine one cycle is 360, right? Or 2 pi equal to 360 degrees. Then because this is a 1x, this in front here sine x, that means you have sine 1x, that means one cycle, right? So that you divide it by 1 here. Then that you come out become 2 pi or 360 degrees. That's why when you, every time when you plot graph sine x, cosine x, you know right away is a 2 pi or 360 degrees. Okay, now if we have 2x, gonna be 2 cycle, correct? So in this case, we can find our period. Gonna be 2 pi over divided by 2, because we have 2 here, 2x, so you divide by 2. Or if you do by degree, you divide it by 2. So gonna be pi. And this gonna be equal to 180 degrees. So let's see the difference now. Okay. What else we're gonna talk about? Then next one, maybe we try how to plot this graph for the sine 2x. Okay, so this one can be this like our, we assume this one, we call this as a B, and our C 3 here we call represent with a C. So actually our form, now we come to plot this graph when our function y equal to 2 sine 2x plus 3. Okay, now see that we have 2x now. Okay, first we find out first how many period we have for this graph. Okay, so we just know, we know already, we talk about the formula y period. So because sine one complete cycle is 2 pi, right? Or 360 degrees. Then you divide it by 2, because right here, number 2 here, tell us. Okay, so we divided by 2. So we will have 180 degrees or equal to 1 pi. Okay, so that means we know one complete cycle equal to 180 degrees. That means if you, when you plot graph, you will complete. In this case, 2 sine 2x, that means have 2 cycle. When 2 cycle and within 2 pi. within 2 pi, okay, 2 cycles within 2 pi. So we plot graph first how to do. But first of all, if we have this one, say if we have our sine equal to sine 2x. This x, remember when we learn the transformation of the exponential function, transformation exponential function of exponential function and logarithmic functions. This will related about a k, right? This one will relate about a k. So your k have to reciprocal. So your k right now gonna be 1/2. Okay. When you talk about this position, it's gonna refer about regarding about the horizontal translation. This one is still in the direction, but talking about the horizontal, the x horizontal moving, y stay. Okay, so now we're gonna plot graph by that concept. We don't use a table yet. Okay, so now we how to do this. Mean every point of x value will compress or become narrower, have just say time 1/2 or divided by 2 for every point of x. So every point of x here, for example, we have pi over, say this one is like a 90 degree here, or pi over 2, right? 90 degree. So you have at this point, okay, when come back to this point. So say if I have pi over 2 here, time 1/2. Time 1/2 gonna be pi over 4, right? That means this one equal to 45 degrees. Means our O point x, original O point x here, OX pi over 2 will move to the new point, which is equal to, at this point is a pi over 4 or 45 degree. But the y did not move, right? So they have the same y, same value of y. So from the O point x here, 90 is up here is a 1, right? It's equal to 1. So when you move to the new point, which is equal to pi over 4, they will have the same value 1. So they're going to be the same height here. So your new point going to be here. Same value of y, but the x moved now from pi over 2 to pi over 4. Okay. So, and at this 0, okay, at the 0 point, 0, then if you 0 time 1/2 time k, okay, 1/2 right now mean k. 1/2 right now here, it means k. So 0 time 1/2 gonna be 0. So at this point, doesn't move, correct? Okay. The blue one, A1 know already, okay, there's a graph of y equal to sine x. Right now we plot number 1 because I think I skip this one because everyone know how to plot it. So we go the second step, which is this one, the one we want to learn today most, okay? It's a new one. Okay, so we come back to continue this graph of the function to here, y equal to sine 2x. Now we go next, if for this point, okay, if and this midpoint, this one should be 3/4 pi, right? This one 90, 180, so this is a 180 degree, this is a 90 degree, you find the midpoint here. So 180 plus 90, 0.72. So then you divide by 2, gonna be 2,125. So gonna be, at this one gonna be 135 degree or 3/4 pi. Okay, so then you just see if this point 135 degree, you want to move this O point, you want to move where gonna be, right? So you use 135 times 1/2 again. 1/2 is our k. 1/2 is our k, okay? It's our k here. So now this one become divided by 2 is about 67.5, right? It's a degree. So that means 135 or 3/4 pi will, the O point here will move to the new point about 67.5. So it's gonna be around here, 67.5. So from the height or the value of y of 135 is up here. So when you move to the new point 67.5 here, gonna have the same height. Okay, so from there to here, gonna the same value of y. Okay, so now I should use the same color, right? So this one for the graph number 2, and then this one 67.5. Okay. After this, what we have here, then you move. We have this point now, right? 0 and 45 up to 1, and 135 move to here. Okay, so we have this 3 point now, right? 1, 2, 3 here. So we try this point, 180 degrees. What the new point gonna be? So you use 180 times 1/2 times k, so equal to 90 degree, right? Or pi over 2, 90. So 90 degree is gonna be, so that means this one pi, right? 180 move to here to this point, pi over 2 here. But this pi here 180 degree, your value of y is 0, right? So your y should be the same at this point. Move to the new point, x move but y the same values. So this is gonna be 0 right here. So that we have how many points now? This, and this, and this. Then we can plot the graph. See how it look like. So you plot the graph right here, up, and down to this point, 90 degree. Then from this one, pi over 2 to pi, right? You find the midpoint, that means 135 degree or 3 over 4 pi. So because we know this one cycle of this question gonna be 180, then we know this another half circle gonna be around here. So this is a midpoint. You should bring then our minimum point should be this one, right? Same point, same level, or this one, because this one's a negative one. Same with the 302 pi or 270 degrees. Okay, so then you move this one down. Well, this is a midpoint, bring down here, make the negative one here, from here. Okay, I'm trying to plot as much nice as I can. And then you draw down here and down here. And then you're gonna make it here. So now you see we have one cycle now, 0 to pi. 0 to pi. So one cycle, right? So we need one more cycle because this step 3, if we have 2, you must have 2 cycles within 2 pi. So then now we can observe by from the previous one. So this half, you break it down, become half here. Okay, now another half here and another half here. So the first half here should be the maximum point, same at this one. Same equal to 1 here. So draw up here, because they will go up like this and down here. So this midpoint of the last section here gonna be the y gonna be go down equal to -1. Same at this point. Same at here, -1. So they made it right here. Okay. So now we know now gonna be this point and this point and this point and this point. Now you will draw the graph up and down. Ooh. And up. Okay. Not really correct. This one should be bigger a little bit. Okay. And this not overlap. Okay. These two lines not overlap. Should be, this one should be down here. Okay. Okay. So this one should be a little bit long right here, but you just get the concept, the idea. Okay. because it's really hard to plot graph on the tablet. So we have 2 cycles, right? For the function y equal to sine 2x, come 0 up here 1 cycle, and there's a second one here. Within 2 pi, 0 to pi. So according the formula period we have. So that's a graph number 2. Okay, now we go function 3, y equal to 2. This one, I think most of you know already how to plot, correct? Because same with the previous class, time to the dilation, right? This one is a what vertical translation, correct? And this one time to, because our is our a greater than our a here is greater than 1, so this one should be stretching, vertical stretching graph. Okay, our y gonna be larger number, higher number. Now we start to plot. If sine, if the x sine, this is x0, then time 0, 0, time 2, 0, so that doesn't move at the same point. And then this is if sine 2x equal to 1 now, right? So you time 2 gonna go up 2, right? So 1, 2 here. So this point 1 gonna move up this point. And then 0, 0, correct? And negative 1 gonna become negative 2. This one we can go a little bit faster, correct? Because everyone know already how to plot. And then this one 0, 0, and 1 move up to 2. Should be the same level here. And then this is 0, that's a 0. Then negative 1 move down to negative 2. Negative 2 here. 0 at the same point. Okay, now we plot graph. Join all the points. Ooh. And down here, go up. Should be cut at this point, okay? And then up here, and go down, make this point, go down and cut to your 2 pi, and then make at this point. Okay, this is graph number 3. Okay, this one should be 2 here, allow here, 2. Okay, so now you plot the last graph. We use a purple color. Okay, then plus 3, right? This is a vertical translated vertically upward 3 units, right? If you like the word. So from 0 here, right? Plus 3. So 1, 2, 3. Gonna at this point. And then this 2, you plus 3. So that means you plus 3 is gonna up to 5, right? This is 4, 3, 4, 5 here. So from this gonna be moved upward, become at 5 here. And then this is a negative 2 plus 3, right? Gonna be at 1 here, correct? Up here. And then this one 0, this point, and then this point 0, and then move up, it's gonna be 3 here. From every point, this one move 3, this one 5, this one 0 become 3. This one negative 2, this up to here become 3. 0 here plus 3 gonna be the same level of here. And then 2 plus gonna be same at half on the top here 5. 0 plus another 3 gonna be right here. And negative 2 up here gonna be the same at y equal to 1 here. And then 0 plus 3 gonna be at right this point. Now we draw the graph, draw the point. Oh, hopefully it should be okay. Now you plot graph up here, down, up here. and down here. Okay, just our graph should be symmetry nicely, okay, but because my scaling may be not really equally for each scaling here. So if you have ruler, please, right, you can scale it equally, then your graph will come up nicer than what I did here. But right now only get the concept, the idea how to plot. Okay. That's all for the graph we're gonna plot for these functions. Talk about our sine. Right now, not only one x can be any number, right, which is greater than 1 or between 0 and 1. Then from this graph, we can read the value of domain, right? Now what the domain is. Okay, our domain gonna be equal to what is our domain? In this case, if the equation specific domain, then you answer whatever they say. Like for example, this one at the picture here. Question should be assigned at this one, right? And then between 0 from 0 to 360 degrees. So you answer this one for domain, for this one. Okay, so you answer this one. Our x gonna be this one. 0 to 360 degrees. Then if question did not specific the value of x or the domain, you have to answer as a equal to real number, right? I use different color. If question did not specify the domain, you have to answer your domain as a real number. Or sometimes you can write it like this, next infinity to infinities. But don't forget, if in this case, right, if the domain equal to real number, when you plot graph, actually you have to plot another cycle by side, right, to the right and to the left at the same thing, but we plot it out here now. So instead, you save our time. You just represent with the arrow for both, for every point of a graph for both sides. Everyone get it? When I write arrow, that means you answer your domain equal to this. But the question specific the domain, you write the dot at the end point of the graph for both sides. Okay. And okay, next, if we answer for word range, you see max height from where y, high here, 5, low is 1, right? So your y or range gonna be close at 1 and close at 5 here. So then this one is a minimum value equal to 1, and 5 is a maximum values. Okay, this is a max. This one's a min. Okay. Then what else? Amplitude equal to, you use absolute max minus minimum point divided by 2. So this one we have max is what, 5 minus min is a 1 divided by 2, so equal to 2. Okay, so you observe this one. Okay, our 2 is the amplitude answer. At the same time, you can observe here this position, this one is answer for the amplitude also. Amplitude equal to 2 also. So that means we can read the answer for the amplitude or the height or the distance of the graph right away equal to this one. But this is a formula. Okay. What else? I think that's all for this graph. Okay. Can I give you a little bit more? If our sine becomes less than 1, I mean, okay, yeah, less than 1, for example, go next one. We go a little bit more here. Say if our y equal to 2 sine 102x plus 3, for example. So now, you see this, our right now become 102x, right? That means our k equal to what? Reciprocal become 2. So right now, this our graph gonna be shrinking or stretching. This is the horizontal, okay? Because when talk about x gonna be horizontal. This one gonna be, because k become 2, so every point, the all point will time 2. So there's the value of x gonna be larger, right? So this is one cycle. Okay, so we have this is a 1 cycle here. This is a 2 pi. And in this one gonna be 4 pi. Okay. So your graph gonna be this a pi. This gonna be the maximum point, and this one gonna be down here equal here minimum point. This is a 1, and this is a negative 1. So when you plot graph here, gonna be like this. Okay. So you see this gonna be this from 0 to 2 pi, 2 pi to 4 pi. That's a 1 cycle. That is answer for when your y equal to sine 1 over 2x. That's equal to this one, 4 pi, 0 to 4 pi. Okay, that's a graph of y equal to sine 1 over x, 1 over 2x. That's 1 cycle. Okay, I think that's all. Okay, we come to the conclusion, okay? Between the 2 examples we did, when our x here is a 2x, and this one become less than, just say this is greater than 1, this is less than 1. Okay, and the conclusion, the graph, we take a look. So this one gonna be 2 cycle, 1, 2 within 2 pi. So you're gonna have 2 periods. So we have s here. You're gonna have 2 periods. Okay, and then for the another graph, the when is a less than 1. Okay, less than 1 here. You're gonna have 1 period within 4 pi. And you can observe, see this one, if 2, right? One more time, we conclusion. I use another color. How about this? When this one, right, 2, mean our k equal to 1 or 2. So the graph is shrink, right? The graph is a horizontal shrinking. So you see the shrink become 2 period within 2 pi. Okay, that means our x, every point here, the new x, the value of x from the old one have to times 1 or 2 or divided by 2 can get the new x. That's why your graph is shrinking here. Okay, now if this one, when you see this one less than 1, so that means our k reciprocal it become 2. So then this can tell us the value of x, the new x gonna be larger, right? That means is a horizontal stretching. The x gonna be larger. That's why you got one cycle expanded very large here, but this one very small. Shrink it up, become 2 cycle, but this one expanded because of this thing. Because the x time it up, so become larger. But this one, your x is divided by half. Okay, that's all the idea today. We learn horizontal translations. I think that's all. I will give you some questions to practice. See you next class. Bye bye.